today we're going to be talking about proliferation, the proliferation platform as it exists in version 10. And it should be a pretty quick tutorial. But if you guys have any questions, what I recommend that you do is use the chat box to ask a question during the webinar, and then after it finishes, I will come back and try to answer those questions one by one. Before we actually jump into Flojo itself and start working with the model, what I would like to do is just kind of go over a few of these slides, just to get you an idea of like how to approach the experiment and some things to keep in mind when you're doing these types of experiments. Well, let me advance here if I can. My arrow keys don't do it. I have to use the mouse. Okay, first of all, where to find help. Okay, all of our documentation is on our docs site. So if you just go directly to docs.flojo.com, you will see a page that is essentially a version 10 manual. You can access that as well directly from the flojo.com website. It's just a quick route here if you copy paste the URL. Flojo University is where we have a whole bunch of short video tutorials, a lot of learning materials, especially for those of you that might be new to flow cytometry. There's a lot of different topics that are covered, and I think it's you have a treasure trove worth of YouTube videos and things of that nature to work with. So in case you're someplace, the easiest way to do that is just go to Flojo University, which again can be accessed from our flojo.com website, and you just click on Flojo University, and there's a series of all kinds of videos and things of that nature there too, as well. The quick answer, if you have a question regarding anything Flojo related, whether it's a biological question, something you can't find, something you want to learn how to use, maybe there's a statistic or something that you're unfamiliar with, just simply send an email to tech support. They'll get back to you generally within 24 hours, and they're located on the West Coast, so they're in the office generally around 7:30 in the morning till about 5 in the afternoon. And again, they'll generally get back to you within a day. All right, so the first thing that we're going to end up doing in this webinar, of course, I've already actually set up a workspace, so we're going to skip over the adding of samples and the gating of population of interest, but we will model the control and then apply that to the group. One thing I will make mention of here is when you add your samples and you create gates on the populations of interest, try to create gates, on a clean population of cells that should be the ones that are going through division, the ones that you want to model using the proliferation platform. If you have a mixed group of cells, what ends up happening is because each cell has a different size, right? If you're using, for example, lymphocytes and you also have monocytes or other granulocytes mixed in and you don't separate them out, right? The monocytes are a little bit larger than the lymphocytes, and they'll cause your peak populations in the proliferation platform to broaden out. The same thing goes for other types of tissue. I wouldn't recommend this model for adherent tissues unless you've got adherent cells that have been adapted to growing in culture. And again, that has to do with the size of the cell. If the size of the cell is fairly uniform, it helps to detect those division peaks really easily. Okay, but if you're using adherent cells, because adherent cells are very different in terms of their size and shape, a lot of times it's a lot harder to model proliferation. Okay, and this is just a slide showing you how to load your samples. I'll skip through that. Okay, again, the gating tree, make sure you're gating on something that should be going through the proliferation platform. So again, you want to gate on the cells of interest. In the experiment that we're doing here today, I've gated on CD4 positive T cells, and we're going to take a look at those here momentarily. If you're interested in these slides, they just kind of point out where you know, a lot of the features within FlowJo are, and these again are clicks that I've already kind of gone through. The proliferation platform node here is located underneath the biology band. The biology band can be accessed from either the tools tab or the FlowJo tab, so it's generally located in both locations. It also is kind of dependent on which version of FlowJo you have. We're at version 10.4.2 right now, and I know for certain that underneath the FlowJo tab you can find the biology band, and within the biology band are all of the specialized platforms. So your cell cycle, kinetics, population comparison, and of course today's topic, proliferation modeling. Okay, we're going to begin the modeling today using our unstimulated control sample. So this will be a fully stained sample, but has not gone through division. We use that to set the undivided peak. And then there are a few other steps that we will take to identify some of the other controls and eventually the experimental samples. Okay, this slide just kind of talks about fixing some of the constraints. The model does generally a pretty good job if you simply set the undivided peak and the number of peaks that you expect in the experiment, and then the other controls can be modified if the model doesn't fit the data very well. But most of the time, those two components are all you need. All right. So again, these are just slides kind of showing you where you can do things and how to do things. But we'll do this in FlowJo proper here. Okay, so you can drag things to the layout editor and to the table editor to get your reports out. All right, let me jump out of the PowerPoint here, and we'll go to look at our workspace. Okay, so I've set up a group here just called small proliferation. We don't have too many samples, only 7. Okay, but we have an unstimulated control. Generally, you need to have this. Another type of control that you should have in this experiment is an unstained control. Whether or not that sample has been stimulated, you always want to run an unstained control just to get an idea of what the background looks like. Now, unfortunately, in this experiment, we don't have an unstained control. We just have the unstimulated sample that we have here. And if you want to take a look at my gating tree, I can kind of show you I've got a singlets gate, right, live dead gate, then I have a gate kind of crude, but I've got a gate here on some cells, right, and then of course I'm isolating my CD4s. Okay, from there, once you've gated down to the population of choice, go ahead and copy the gating tree to the group, right, and then let's go ahead and open up the biology band. So head over to the FlowJo tab, right, and we're going to click on proliferation modeling. All right, so we click this guy, it'll open up the proliferation platform. Okay, and the first thing that you want to do here is make sure that the x-axis is on the die that you're using. Okay, in this case, we're not using CFSE, we're using 670, something that's along the 670 or 660 detector. Okay, so make sure the x-axis is on the die of interest, otherwise you'll get the wrong output. Okay, so since this is the unstimulated sample, this one reflects the peak, right, where the undivided cells should be. So the first thing that we want to do here is just simply click and drag our mouse across that histogram, right? So you can just drag it across that peak, right? Something like that. When you finish dragging, this little box pops up where it asks you to fix peak 0. If you do that, right, it'll give you a shaded peak or a shaded histogram here, a shaded gate within that range gate region. You could have also used the range gate tool here up at the top. You can click and then click and drag. But if you just click and drag by default, it'll do it. Okay, once you add the undivided peak, on the right-hand side here of the panel, you'll see a whole bunch of statistics, right? So it will add the undivided peak. So this right now is telling me that, all right, in the undivided generation, I have roughly 4,700 cells. The current model is calculating for 4 total peaks. So it actually has 4 other histogram peaks that are in this model. You can't see very well because it's been flattened out. We'll touch this number a little bit later Okay, but that's what the other generation statistics here are telling you, that you have roughly 234 cells in the first generation and then about 30 in the subsequent ones. We won't worry about those numbers too much yet. Okay, so once you have set the undivided peak, what you want to do here is you want to go back to the workspace, back to that sample, okay, that you initiated it on. And since we made a change to the proliferation platform here, what we want to do is we want to copy this now to the rest of the samples. And every time we make a change, especially where we're constraining the model from a control sample, we want to copy everything that we change over to all of the other samples. Okay, so I set the undivided peak. Now I would like that to be represented for all the other samples. The quick way to do this is to simply right-click on the proliferation node itself. And what you will see here is this option in the middle of the menu that says Copy Analysis to Group. Okay, there's a really nice shortcut here, Control-Shift-G if you're on a PC. If you're on a Mac, it's Command-Shift-G. Right? You just click on that, and then that will take the proliferation node, right, and it'll place it gating hierarchy. Right? So now all samples have that proliferation node. Okay, and if you click the little green arrow within the platform itself, right, you'll see that we can advance. And you see how I'm going to different samples now, but that undivided peak, that shaded peak, remains in the same position. Right? We don't want to change that from sample to sample. We want to keep it in the same spot because we fixed it using our fully stained but unstimulated control. Okay, now the next number that we have to work on here in terms of getting the model to work right for our samples is the number of peaks. Okay, so generally speaking, what you want to do in this case is you want to go through your samples and find the one, well, that's not really good. Let's go ahead and reopen that one there. My apologies. I'm using an old data set, and I think that Flojo doesn't like this FCS version 2 data, but good thing I have a saved workspace here. So we'll go ahead and open up that small proliferation workspace and get that little chime going. Okay, and again, I'm going to return to, all right, we're going to return to this guy, say biology, proliferation modeling, change the x-axis over to the die, go ahead and add that peak. Okay, and then we're going to copy that across to all the rest of the samples. All right, did I not click that? All right, something's amiss with that. Let's try and do the old drag and drop. That never fails. All right, so again, let's go ahead and save this just in case. Okay, and now we want to advance to some of the other samples here. Again, looking for the sample that has the nicest set of peaks, clean peaks, right, that are easily countable. You see how these other samples here are kind of modeled? It's a little bit difficult to identify all the different peaks that are present. Okay, but I've got a really nice one here where the divisions are pretty clean, pretty straightforward. Okay, so we go from here and we count the number of peaks, including the undivided peaks. So we say 1, 2, 3, 4, 5, right? I can see 5 peaks by eye. Come down here to the constraints, right, and say the number of peaks that I'm going to add here, right, is going to be the number that I can count plus 1. So instead of 4 here, this is going to be 6, right, because we counted 5, 1, 2, 3, 4, 5, and add 1, okay? So you add 6, hit the enter button, you'll see a few more generations pop up here. In total, we'll have 6 generations, okay, and we're on the PD50 sample. The sample name is listed at the top here. And again, since we made a change to the model, let's go ahead and copy this, right, to the group so that all other samples pick that new change up. Okay, we'll go ahead and do that. I like to save after a few steps here. Okay, now the next thing that I would do is if I happen to have the actual file, which unfortunately I don't, but if I had an unstained control, what I would do is I'd go ahead and open up that unstained control and just look to see where the histogram from the background sample, how far forward it goes, so that I can set the background staining. Now, it's not necessary that you do that. In fact, what we have now for the model generally works pretty well. So if we actually just kind of walk through the samples here, right? Open up the proliferation platform here. You can see you've got all your generation stats. Okay, and then if we walk through the samples here, you can see that the model has, is being applied to everything in the data set. And one thing to kind of keep aware of here is this statistic on the just above your generations, the root mean squared. I should have mentioned this earlier, but the root mean squared is a statistic that tells you how well your model fits the raw data. So the model here is outlined with the green histograms, right? If you want to see the total, what the model is bringing in total, you can tick the box here where it says draw model sum. This will draw a red line or a pink line around the entirety of your data set. Okay, and it's essentially the distance between this red line and what's going on with the black line that the root mean squared is measuring. So the smaller this number is, the tighter the data fit the model. Okay, the larger it is, the further away it gets. So the idea is, with the constraints, we can try to bring this down. Okay, and what I'm going to do here is I'm going to say for the fixed background, again, if I had a sample that had the background, if I had an unstained sample, I would go into that sample and try to estimate exactly where the front end of that histogram went. So I'm kind of doing this blindly, but we would say fix the background, again, using our unstained control. And I'm going to assume just by looking at this graph here that, I don't know, maybe the back end of this histogram kind of tapers off around 500 someplace. Okay, but your unstained control would tell you where that boundary is. So you can come in here, fix this maybe at 500, again, click enter. Okay, and then what I would do from there is just monitor that root mean squared. Again, if this jumps up, right, the model is getting worse. If it goes down, the model is getting better. Okay, if it doesn't jump sharply one way or the other, I wouldn't worry about it. So in our case, it went down by 1/100th of a point. Okay, so we didn't really do too much to affect the model. But since I've added this, right, I'm going to go back to that sample, right, and I'm going to add that constraint now to the rest of the samples again. So every time I make a change on a control, I'm going to add it. Right, now, another thing that you could see here is you see how the histograms are kind of, in my opinion, to the eye, these histograms look a little bit wide and they're a little bit shifted to the right. Okay, so these guys look a little bit fat and shifted towards the right. Now there's two other constraints here that will control those aspects. Okay, the one that I would work with first here is the fixed CV. This one changes the size of the histogram's width. Okay, so currently that statistic can be found here where it says peak CV, right? Roughly 4%. Okay, if we bring this down, it will narrow these histograms. So I'm going to go ahead and say fix CV here. Okay, and I'm going to bring it down to maybe, I don't know, let's see what happens when we take this down to 3. Okay, when I enter 3, you can kind of see how that trims up the model, right? The histograms look a little bit thinner. The model does jump up from 1.5 to 3.4, but we're not going up a full point here, so I'm not too concerned about the increase in the root mean squared. And in fact, if you look at the model sum, right, the model sum's trace is closer to what we see with our eyes. All right, now the next thing, let's play around with this and just see what if we put a narrower CV, what would happen, right? In this case, again, we kind of tighten up those shoulders, but you see how the root mean squared now has jumped up to 4.5, right? So that change may be good to the eye, but not good statistically regarding how well the model fits the data. Okay, so maybe 2.5 is, not as good as our 3. So I might return this back to 3, right? Get that jumping back down to under 4. Okay, and then the next thing that I'm going to do here is I'm going to look at the peak values. You see how the peaks are a little bit shifted towards the right? The fixed ratio aspect here will allow you to to move those peaks a little bit more towards the left. Now, this one is particularly important, again, when you have a nice, clean set of cells. That is a set of cells that you've removed the doublets, you've removed the dead cells, and you have essentially cells of a uniform size. Every division, right, every time the cells divide, they should give approximately half of the dye to the following generation, right? So to the 2 daughter cells, each of them get half of the dye that the parental cell had. Okay, so this is essentially what the fixed ratio statistic is doing, is basically telling you what's the percentage of dye that goes to the next generation. Okay, so if we tick fixed ratio, the current fixed ratio statistics is 0.51, which is a little bit strange. It's saying essentially that each daughter cell receives 51% of the dye, which is biologically impossible, right? But this statistic is also very sensitive. So let's go ahead and make it, first of all, biologically relevant by lowering it down to 0.5 and see what happens to the graph. Okay, not much is visible there, but we did bring down the RMS, right? We were at 3.4, now we're down to around 3.17. So we're fitting it a little bit better. Okay, again, this statistic is very sensitive. So if we just move it down by 1/100th of a point, right, kind of see those peaks are slowly shifting towards the left, right, as we lower this number. So again, I'll give you an extreme case here. Look what happens when we add it. We make it 0.45. Now we shift the peak so far to the left that we're a little bit off. And again, the root mean squared jumps back up, in this case, over 4. Okay, so probably somewhere around 0.48, right? 0.49. Ooh, look at that, root mean squared of under 3 even. Okay, that's pretty good. The peaks are fairly well matched up, especially with the latter ones versus the ones in the very beginning. I'm not too worried about these guys, especially because the latter populations here seem to match up pretty well, and the RMS is pretty good. Okay, again, we can try to trim up those CVs, because to me, by eye, they look a little bit fat. All right, so if I bring this down, maybe make it 2.8, right? Thinning those peaks, unfortunately, right, thinning the histograms is causing us to go up in the RMS. So these are not great changes, but I'm still going to try and satisfy my curiosity here. And I'm only making things worse, even though by eye, these look good. The model is telling me you should probably stick with right around 3, because you got a nice RMS there. Okay, so this is the hard part. It's kind of balancing the RMS with what your eyes see. And remember, the statistic, the RMS, is just measuring, right, how closely the model fits the data. This happens to be a pretty good number, right? It's the lowest number that I'm getting out of all of the constraints that I'm setting. So this is a pretty reasonable way to go, right? And so what I'll do at this point is I'll say, this is the model that I want to fit to everything else. The sample we're looking at is this PD50 sample. If you go back to the workspace, there should be a blue diamond, right, marking the proliferation node that you're working with. And again, we're just going to take that and copy it to the group, because we've made changes to the model, and we want all other samples to have this reflected, right? So if we go through, open up the first sample, right, everything now is being modeled using the constraints that we set on the control, and the really nice model that had all the very nicely separated peaks. Okay, and then we can just kind of scroll through here and just see what the divisions look like. Right, monitoring the RMS, but also monitoring the number of populations that we have downstream. So normally what's going to happen is you're going to have, you know, for whatever the peak value is here, you should have a decent number of cells, right? So there should be fewer cells kind of ramping up at this point. Generation 2, you'll have a little bit more, and then it'll drop back down. Okay, you can visualize the peak numbers if you want by ticking this box here where it says show peaks, right? So you have the 0 peak, the 1, the 2, the 3, 4, and 5. All right, so we'll talk about some of these other statistics up at the top a little bit later. But generally speaking, to kind of sum up what we've done here is these statistics that are sort of in the middle of the pane are referring to the constraints that we've set on the model here. The statistics that are located here that refer to the undivided and the various generations, right? These are all of the statistics associated with the peaks that you see in the proliferation model. All right, so at this point, we can take this information and we can apply it to the layout editor, right? So you click on the L button here at the top, right? This will open up your layout editor, which is like a sheet that allows you to create plots for all of your graphs and so forth. All you have to do is drag over one of the proliferation nodes if that's what you want to see. It'll put your model here, all the statistics that are associated with that right panel, and then it'll have an annotation down here at the bottom. From here, you can batch this if you'd like. Right? So you can put this, I don't know, in columns going down, just so it's easier to see in my case here, so I can show you everything. Right? So this is sample. This is the first sample that appears in the workspace, right? And then I have the second sample, third, so on and so forth as we go through. Okay, again, it's wise that every so often save your work. Okay, if you want to get rid of this panel, maybe you don't like these statistics being here, you want to add them as a table or something else, you can always just highlight that and delete it, and then we'll work with the table editor here in a moment to do it. Now, a lot of times what people like to do is they want to compare one set of maybe peaks or one proliferation model to the next, right? You'll notice that if you try and drag and drop these guys on top of one another, right, you can't create the overlay. Okay, the reason that you can't create the overlay is, well, first of all, it's just because it's a calculated model. It comes from a proliferation node. This also happens for cell cycle. You cannot overlay the proliferation node's graphs. But what you can do is within the model itself, you'll see here underneath the proliferation drop-down menu, there's this option to create gates. Right? So if we click that button, it'll go ahead and create a series of gates that are based on what the model is finding here in terms of the histograms. Okay, so you create those gates, you go ahead and select these guys, right? And again, you can apply them to the rest of the samples in the data set. So in my case, I'm going to have to drag this actually underneath the CD4 population. Okay, and it'll create those gates for you. Now, once you have those proliferation node gates, now you can take these and you can compare them to one another. So you can create your own set of overlays. I'll remove this for a second. Right, just to give you an idea, here would be, here would be the first set of gates for the first sample, and then if you want to overlay that with, right, the second sample, just go ahead and drag the other set of gates on top. Okay, you can do this. You can do this by generation. So if you want, for example, to select only, let's say, compare the second peak, right? We'll take division number 2 from sample number 1, and I'm going to move this over so you can see this, right? And you want to compare division 2 from the first sample to everything else, or maybe just a few, right? If you just simply right-click on that proliferation division 2 gate, you say select equivalent nodes. Okay, Control-Shift-E right here. What that will do is it'll highlight division 2 from all of the other samples that you have, and now you can just drag that over, right, and you can get an overlay between all those samples. Now it'll represent whichever one you brought in first twice, so you can get rid of that by simply clicking inside the legend and saying remove layer. Okay. Alternatively, this is actually useful if you want to set it as a control, so that that control peak shows up in every plot as you batch it. You can set it as a control and it will appear in the background. Okay, you can also control the colors, as you saw there, right? In my little color palette, you can also control the tinting and the line styles for each individual plot simply by right-clicking on it in the legend. Okay, if you want to just have a couple of samples overlaid here, you can go ahead and highlight the ones that you want overlaid and then remove the ones you don't want. So you could say remove layer here. This kind of helps you, instead of having to sort of go back and forth from the layout editor to the workspace, you can create the massive overlay and then just delete what you don't want. Okay, so in this case, maybe I'll set this up to batch. I'll set one of these guys, the sample 5 here, to be as a control. It's probably not the right one to use, but I could set that as a control. And now let's change this also. There's another thing you probably want to do here is, rather than looking at these peaks overlaid on top of one another like that, you might want them offset. So if you right-click on the plot itself, right, there's histograms here. You can say, put this on an offset, right, so you can see them all differently. I kind of like this one down here where it says stagger offset, right, because it gives you that nice little angle, and you can kind of move it around to what you want. I suppose if you wanted to recapture to some extent that full offset, you just pull it all the way up to the 90-degree position. Okay, so we set that up. Now we can go ahead and batch this, but you'll notice up here there's a batch, the batch options are broken. All you have to do in order to restore that is tell it essentially how many samples you have laid over with one another. So in this case, what we want to do here is change the iterate options. You'll see this is generally set to off. Okay, click this button, change it over from off to panel. You can also do keyword. Keyword's a little bit more difficult, but panel is pretty straightforward. Click on this. What ends up happening is a little box will open up to the right, and it's basically just asking you which or how many samples you have overlaid with one another. Okay, in my case, I actually have 2 samples overlaid with one another. It's just the first sample is represented all the while maintaining a lock on that first sample as a control. Okay, so we go here. Again, we'll make a batch report going columns down. Okay, and this kind of teal color is the one that's being locked in the background. You might, use, I don't know, your undivided peak or something like that as the background. I just picked generation 2 as the control, which probably doesn't make sense in this experiment, but just to give you an idea of what it does. Right? You can lock that peak. Now you can see PD50, PD10, right, being overlaid with one another. Right now I can see, all right, here's my unstim with, well, we ran out of samples, so that's why this is blank, but unstim with that control right here. Right, so on and so forth through that batch process. But the key thing there is when you want to batch and you have 2 samples that are overlaid with one another, just make sure you change this over to panel. Okay, there are several other batch export options. You can batch here to PowerPoint or PDF. You can also save the image underneath the File tab here. You can say save it as PDF, SVG, or TIFF. You can also save it as the bitmap image types. The SVG is really nice because you can ungroup the objects in Adobe Illustrator. There's a bunch of freeware for PCs that will open SVGs, and Inkscape will also open an SVG, and you can ungroup all of the objects. The other nice thing about SVG is that you can open this this graphic, this plot, and you can stretch it, right? You can stretch it out or you can compress it, and you won't lose any resolution. So open it up as an SVG, stretch it out, save it as a different file type, and get a higher resolution if you need it for a journal or something along those lines. Okay, but that's the general idea behind using the proliferation platform in the layout editor. Just drag and drop what you want. You can create overlays using those gates. Okay, so those gates are located here underneath the proliferation. You say create gates, and it'll actually create the hard gates for this particular sample. Now, I will caution you, the create gates button here, when you create these gates, you'll notice that the divisions that you have are not going to match up what the model has. So we're looking here at the blue diamond. This is the proliferation node that's opened up for sample PE10, right? Division number 0, I have a count value here of 387 events, and then it increases from there. Now, if you go back to the proliferation platform, right, my undivided peak has 238 cells in the 0 peak, right, or the undivided peak. And then we go 700, 1200, 900, so on and so forth. Okay, those numbers are not the same as the numbers that you get here. Now, the reason that is, okay, is that the model is using a probabilistic model. There's a probability that a cell belongs to one peak or the other. So the model is using a mathematical means of determining the generations. And these are the stats. If you're going to be working with the statistics, these are the statistics that you want. These gates here, the only purpose of these gates is so that you can create overlays in the layout editor and see if one is shifting to the left, to the right, etc. Okay, so we do have a question here, but I'm going to jump onto the table editor, and I'll come back and answer that question for you in a moment. Okay, so to open up the table editor here at the top, right, you'll see this screen looking character. Right next to the L, this is where we go to export our Excel files or CSV files. This is where we export our statistics from FlowJo. So if you open this up, again, you get kind of a sheet interface, right? And from here, all you have to do is just drag in that proliferation node, and it'll take all the statistics that are associated with the platform, and it will present them here, right? So all your generational statistics are down here towards the bottom, your RMS and some of the other statistics that are associated with the peak values. A lot of times we don't need these when we're exporting this to Excel and doing those sorts of things, so you can just highlight them and delete what you want. But there are some other indices that you might find useful, so you can keep those in place. Number of peaks and undivided peak median, these are, again, values that you probably don't need for a report, but you could keep them there if you want. Okay, if you want to kind of make the table look a little bit slick, go ahead and highlight the statistics here that you want to heat map. In my case, I might heat map my different generational values. Go up to the Visualize tab, click Heat Map, and now you can click that little batch button here, or you can go to the Table Editor tab and say Create Table. Both do the same thing. All right, it'll open up this Table tab, and you'll see the series of statistics that are highlighted in for heat mapping on one side. I will mention that you'll see generation 6, 7, and 8 over here. The stats are all NA. So by default, when you drag in the proliferation node, right, it essentially includes statistics for up to 8 peaks by default, even though you're not using that. So we technically the latter 3 we don't have in the model, and so that's why everything here appears as NA. And then, of course, all the other statistics here are indicated as well. You can copy paste this directly to Excel if you want. You can also produce the table. So if you want to actually make the Excel file, come over here to the Table Editor tab. This is the default interface. Click this where it says Display. Click the drop-down menu and just change this to to file. Okay. From here, you can change this to CSV or Excel. Make sure you know where this is going. Right? If you click here, you'll see. Tell it where you want it to go. I could call this Jack's proliferation table or something like that. Right? When you click Save, it just records the location. Click the table button there, and now it should appear, right, in your Finder or your Explore window wherever you dumped it. So in my case, I dropped it on the desktop, right, and there it is. Sorry, that's not the right one. Mine should be Jack's proliferation table. Anyway, it will end up on your on the location where you sent it to. In my case, I can't remember, and I'm not going to sort through all my files here, but it's somewhere there. All right, so let's talk the last component here before I get to the question that was being asked are the indices. So if we go back to the proliferation platform, right? So you have a percent divided statistic that's telling you, all right, well, what is the percentage of cells that actually went through division? So roughly here, 77% of cells went through division. The proliferation index and the division index are very similar to one another. So the division index is telling you essentially the number of divisions that the entire system went through. So this includes non-dividing cells. So if you were just looking at the total number of cells, how many times do cells divide? 1.3 times. But the proliferation index, which is a little bit more pertinent to the experiment that you're most likely doing, this is telling you how many times the cells that have gone through division on average are dividing. Okay, so this is only talking, the proliferation index is only talking about cells that are going through division, that have actually divided at some point through the experiment. Okay, so of the dividing cells, the average number of times that they divide, 1.7 times. The expansion index is a number essentially that you can multiply with your with the initial number of cells in division 0. So if you were to take that number and multiply it by the number of cells that you had in the undivided peak or at the very beginning of the experiment, you multiply the expansion index with that number, it'll tell you how many cells you have total at the end of the experiment. So in my opinion, the expansion index, it's useful, but it's not particularly, you don't see it reported much. The replication index, I have to check on this one, and this one actually you guys might want to pass to the tech support. This is actually a newer statistic, and I can't remember offhand what this statistic is referring to. Okay, standard deviation has to do with the standard deviation of each one of these CVs, and again, the peak statistics here, all of this stuff, peak CV, peak ratio, background, that has to do essentially with the model and the constraints that are applied to it. Okay, so with that, I'll say that kind of wraps up the general use of the proliferation platform and what you would end up doing, and I'll answer the questions now as they pop up. So we have one in the chat window. It says, when you have multiple patient samples that are unstim and stim, do you pick one of the unstim sample, make your model, and apply to all samples? Do you only apply it to the sample from that same patient? So that's a great question. Patient data are notoriously highly variable, right? So in the ideal situation, this is the perfect world, perfect scenario where you have all the proper controls. You ideally want to have an unstim and a stim for each patient, right? Because every patient's cells are different, and you will notice that the staining is going to be different, even if you stain, let's say, for CD4 cells, or if you just look at the scatter, just looking at the scatter profiles of patients, right? You'll see that, somebody's lymphocytes are, going to be skewed a little bit towards the left, right? Versus others, it'll be a little bit skewed towards the right, meaning that the cells are actually have a different size in one patient to the next. Well, if you use a control, let's say for the smaller cell, the person that has smaller cells, when you apply that to the sample that has the bigger cells, you're going to, the model is not going to turn out as nice, and it's not really, you're really not comparing apples to apples at that point. But I understand that in some cases, where you only have one control for one patient, you try to apply that model to everything else that you have. Yes, that would be essentially the best that you could do. But I would have a control for each one of the patients, unstim and stim, because patient data are just insanely different. So I hope that answers that question. We have another set of questions here in the Q&A. So the first question is, can I change the name of the axis, the dye description in the layout? Well, you should be able to. On most other plots, you can. I'm curious here. I haven't done this in a while for Flojo, but let's test this out, right? We have this comp, blah, blah, blah. Go to your layout, whichever one you're working on. Okay, don't do this with the batched layouts. Do it with the unbatched layout first, because this will, all you have to do at that point, once you change the name, is just click the batch button. So what you do here to change the name is double click on the plot itself, right? And what you want to do is the annotate tab. So the x-axis label is what you're talking about. So I might say, I don't know, 670 die is not particularly interesting, but let's just say it was maybe CFSE that we had used in this experiment, and that's what we want to relabel, right? Enter that, click apply, click OK. It'll replace that. It'll replace that name with the name of the sample that you want. So yeah, it works for the proliferation platform, or the proliferation gates that we created. What we could do here is we could try and test it on this one, right? This is a batched layout, so let's do an unbatched layout to try and overwrite what it has here. So again, I'll go to the annotate. We're going to change this again to CFSE, right? Should take place. It does. And there you go. And if you want something else here on the Y, the same thing will happen. So you could just call this Y param or something like that. Okay, and it'll replace it. So the answer to that question is yes. Okay, and so the other question is, can you please comment on the different index types in the statistics? So I did that. The only one that I don't know offhand is what the replication index is telling us. Okay, but again, the proliferation index is probably the most important to you. The division index is telling you what the whole system is doing, so it takes into account the divisions of cells. It takes into account all the cells that are present in the data set, including cells that are not dividing, and then attempts to give you essentially an average number of times that the cells divided. Right, so that's what the division index does. It tells you essentially what the entire system is doing. It takes into account the non-dividing cells. The proliferation index is telling you how many times the dividing cells divided. Okay, so it's only paying attention to the cells that are actually moving through and dividing, not the undivided cells. So generally speaking, the proliferation index is going to be higher in number than the division index. Okay, and then I talked about the expansion index. This is just telling you essentially what if you take this number and you multiply it by the starting numbers of cells in the first sample, right, it'll tell you how many cells you have total in the end. So it's essentially kind of an index that roughly tells you how many times, how many generations you have in a given experiment. And then the last question here is, how many cells or events should be at least in one generation to have a good, accurate modeling? Ooh, how many cells should be at least in one generation to have? So this is a tough question to answer, simply because on occasion you will have a sample that divides really well, right? So you might have generation number 1, let's say, and generation 2, there might be almost nothing in those peaks. And then way down here, generation 3 or 4, you start to see peaks. That means that the first couple of generations have passed by the time you have sampled the data. And in that case, you could have 0. Now the model sometimes does okay, the other times it doesn't do so well in those instances. And in that case, I would either switch to, if it has numbers here, great. If it has zeros, that's really a tough one. I don't want to say discount it. I'd actually have to see the data and see how the other peaks here model in order to get an idea of what that what the output looks like. So I wouldn't say that you have to have a minimum number of cells in each. The key here to kind of understand whether or not you're getting a good model fit to what the data have, again, is the root mean squared, the RMS. If this number is, let's say you have 10,000 events that you're measuring, and this number is over 10 or 15, then you know that the model and the data are not fitting well. So whatever the generation numbers are here, you could consider as being erroneous, and you either need more samples or more data to fit that model, or you need to come in and constrain the model more to bring this down. But the strict numbers of events that you need to have in any one generation for good modeling, that's, I mean, I can't say per generation, but I would tell you that if your model, you know, here we have roughly 5,000 events that we're feeding into the model, and the RMS is under, you know, is under 5, which is really good. But so long, I generally tell a general rule of thumb here is if you're under 10 and you have about 10,000 events, you're doing all right. Okay, and then the last question she has here are, how many events should be measured in total? Okay, so I think I just answered that. You can see in these experiments here that we've set up, right, we have sampled roughly 10,000 events in the PD50 sample here, which is the one that I used to model the data, and it did a pretty good job getting an RMS underneath 3. Okay, and then the unstimulated sample, of course, we've got 20,000 events, but I would say that the minimum number that you're looking for here is 10,000 total, but again, be more specific about the actual population that you're going to be with. So in my case, CD4s make up a large percentage of the total data, right? So I have 4,500 CD4 cells here, which are roughly half of what we have in total. So I'm going to tell you that the minimum you want to put into this model is going to be right around 5,000 cells. If you have less than 5,000, you know, you'll start to see these histograms sort of have kind of rectangular edges. And when you see models with rectangular edges, you know, then you're out of the ballpark there. Okay, so any other questions? I apologize about the replication index. I think if your emails here have been recorded when you registered, what I can do is I can email you the specific meaning of the replication index here. Okay, but other than that, if you guys don't have any more questions, I'll go ahead and wrap up the webinar. And again, you know, just go to flojo.com, and you can head over to the Learn tab or the Flojo University tab. Check out a lot of the materials that we have available for exploration. Okay, so if you want short video tutorials, right, for Flojo, all of that stuff is located here. All right. Any other questions? All right, well, thank you again, guys, and have a great day.